Hello. In this presentation, I will talk about the applications of functional materials in food science and technology. This presentation includes an introduction, an explanation of what functional materials are, an explanation of the most important applications in the food industry, and some final remarks. So it is important to say that there are many ways to classify or organize materials, but one of the most commonly used is related to the use and importance of properties. So the materials will be structural if the mechanical properties are the most important, and functional if other physical-chemical properties are the ones that determine the final use of them. And it is also important to mention that in most books or articles that talk about functional materials, the food applications are not taken into account, but this could change in the future. So, what functional materials are? These are materials that have been especially designed to have some properties that will help them to fulfill determined functions. These properties could be thermal, electronic, magnetical, optical, or others, but they are unique and made them very special for their uses. Some classical examples of functional materials are semiconductors, polymers, molecular crystals, and nanoparticles. In the image, we could see that in some cases, we could start with some type of material, for example, a polymer, and then through chemical reactions, one or more stages, we can add some functional groups that will modify the properties and improve those that are desired for a specific use. In this graph, we can see that there are other aspects that need to be taken into account when working with functional materials. For example, the characterization. One cannot think of the final use of a material if one doesn't have enough information regarding their properties. Otherwise, it won't make sense to start proving them in a specific use if it is not appropriate for that. Also, it is important to take into account things like the cost of the environmental evaluation. Since, for example, even though a material has many good properties for a specific use, but it is too expensive, it will just not be taken into account by the industry. The most common and classic applications of functional materials are the ones that are shown here. In the graph, we could see, for example, a jar made of certain ceramic with some additives that changes color when a hot liquid is poured into the jar. So it is very interesting, and it is an example of a modern use of functional materials. Regarding the applications in food science and technology, there could be many uses, but in this map we could see 4 of the most important. In this presentation, I will make more emphasis in the packaging, but I will also talk a little bit about the storage and transportation, processing, and formulation. So, food packaging might be the most developed area of the applications of functional materials in food industry because it has been used for a long period. In most cases, the materials are primary packaging because they are in direct contact with the food products. In these cases, they will need to ensure two things. First, the food safety. It means that the materials won't contribute to contamination of the products. And second, it will be useful to extend the shelf life for as long as possible. In these cases, if a material doesn't help to have a long period of time where the products could be commercialized and consumed, it doesn't help a lot. So what are some important properties regarding food packaging? Well, one of them is the appearance. So if a material is very good but it looks bad, the consumers will not buy it. Resistance is also important in order to avoid damages to the product. Stability means that the additives of the materials will not migrate into the food products, causing some toxicity, for example. Gas permeability is especially important with CO2, oxygen, and water vapor. For example, products that are fried must not be in contact with oxygen because it will change the flavors and make them not uh, tasty, or even the texture will also be affected. Other products could be sensible to sunlight. So in these cases, the materials should have some opacity. In most recent times, some additives or modifications in the production of these materials have added biocidal activity to the products. So it's very good news because they will prevent or um, avoid the growth of microorganisms that um, made food ripe too early. Also, in modern days, circular economy is a very important thing, and it, for example, has made recyclability and biodegradability two very important properties of food packaging materials. In the image, we could see most of the most common used materials that include polymers such as polyethylene, polypropylene, PET, and others. Cans that are mostly made of aluminum, glass that is a very convenient material since it is inert, waxed paper that has some specific uses, and polylaminates that are seen, for example, in Tetra Paks or dye packs. In these cases, many different types of materials are combined. Each provides on specific and desired properties. So at the end, these combined materials have better properties than their separated parts. Also, some additives could be introduced in the processing of the food packaging materials to improve their properties. They could make them more stable, for example. Also, blends, composites, and polylaminates have been developed and they include some biopolymers combined with synthetic polymers. So it is interesting because it could change some properties in a desired way. Also, some methods of processing the materials could improve different properties, especially those that are related to permeability or resistance. These processes include extrusion, foaming, high pressure treatments, irradiation, for example. In the image, we can see the example of Tetra Pak. That is a very convenient material to commercialize milk, for example. If the milk has been ultra high temperature pasteurized, it will last for several months without the need of refrigeration. So it's very convenient. In these figures, we could see the results of and study that combined biodegradable polymers obtained from agroindustrial residues into other matrices combined with traditional synthetic polymers. We can see that the um, permeability to oxygen, water vapor, or carbon dioxide could be modified, and in some cases could achieve very good levels. In more recent times, um, the addition of nanometric materials to food packaging have been studied largely, and it has been proved that they could change the rheological properties of the polymers. They could also improve the barrier to gases, mechanical and thermal properties. In the table, we could see, for example, that some tensile properties are changed according to the amount of these additives, these nanocomposites of MNT added to thermoplastic seine obtained from maize. So it's very interesting how these values change uh, in a very clear way. Here we could see how the addition of metal or non-metal nanoparticles to packaging materials could add some important functions such as antimicrobial or coloring or barrier to gases. So this is a very active area of research. Um, at last, um, some nanosensor labels have been added to the packaging materials. They could inform the consumer, for example, if the cold chain have been um, flowed during the transportation, for example. Or it could also tell if the a type of microorganism have growth inside. So this could avoid food poisoning. Also, the addition of biopolymers to other materials could improve their biodegradability or compostability, which is very important nowadays. And also, it is important to say that more research is necessary to prove that using nanomaterials is safe for food products. Regarding food storage and transportation, most of the properties that are desired in these materials are similar to those that were explained for packaging. The main goals are to prevent mechanical, biological, or chemical damages or contamination, and also to keep adequate temperature and humidity conditions. What are the means to do that? For example, facilities, vehicles, equipment, or containers. In the images, we can see, for example, a mean of transportation that keeps low temperatures in the liquid that is transported, so it prevents the microbial growth. In the second case, we can see a box that is very nice and clean, so it will prevent damages to fruits that could be transported there. And in the last case, we see a refrigerator and the indications that tell us where to put some different type of foods according to the optimal temperature. In food processing, the most important thing is to relate them to the unit operations that are part of the processing of the food products. So, for example, in operations such as blanching and pasteurization, which involve heat transfer, it is necessary to use materials such as metals that are good heat conductors in order to have a more efficient heating of the products. In the case of filtration, for example, one could choose a membrane that has a specific pore size, which, for example, will allow some liquids to pass, but will retain other type of particles, bigger particles, or even microorganisms. Regarding food safety, it's also important to have, for example, tables that are made of stainless metals and that are non-porous in order to avoid food contamination. And regarding formulation, the materials could act as the main ingredients. For example, in the case of casein, that is the main component of cheese, or waxes that are added to some products to give them some shine, or even pectins or agar, that is the main component of gelatin, for example. In other cases, they will act as additives, uh, as lecithin, that is probably the most important emulsifier in the industry. Others could act as colorants, such is the case of mm, titanium dioxide or carotenoids. In the final remarks, it's important to say that these physical chemical properties are very related to the applications, and that these properties could be modified with the addition of some chemicals, combination of different materials, modification at micro or nanostructural level, or the processing conditions. Thank you for your attention.